Hello, everyone, and welcome to the Actualize webinar on Intro to Ruby. I am Jay Wengrow, the CEO of Actualize, and you are all probably wondering what on earth is going on here. Don't worry, I can explain everything. So, firstly, I am the Cowardly Lion, and you might be wondering why I am dressed up as the Cowardly Lion. And the answer is very simple. I want to demonstrate that there's nothing to be afraid of when it comes to learning to code, and even the Cowardly Lion can learn to code. Actually, that's not the reason at all. The reason I'm dressed up like this is simply because I lost a bet. Yeah, so that's explanation number one. Explanation number two is you're probably wondering what's going on here with these legs. So if any of you have joined us in the past, you'll know that I usually have an assistant who helps me out. Unfortunately, I do not have my assistant today due to a terrible tragedy. You really don't want to see what's going on here. It's pretty gruesome. So I'm going to do this all alone today. So as you know, you can always type in questions by chat. Since I don't have my assistant today, I'm going to take a few breaks here and there to quickly look at the chat to see if anyone has any questions for me. Feel free to ask them via chat at any time. So without further ado, let's introduce you to Ruby. And really, today it's not as much as introducing you to Ruby as it is introducing you to programming in general. But we'll use Ruby to introduce you to coding and what coding is. So let's start with, what is coding? What is computer programming? And coding and computer programming are synonymous with one another. So it's simple. People think that coding is something that is like rocket science, but it's simply giving instructions to a computer. So a computer is just a dumb piece of metal, doesn't know anything about anything. And when giving instructions to a computer, you have to be very literal. You tell it one instruction at a time, and it follows your instructions. So Ruby is a programming language, meaning it is a language with which we can communicate with the computer, because the computer doesn't understand English. It only understands certain programming languages. And Ruby is one of those programming languages. So when we talk to the computer using Ruby, we can tell the computer to do whatever it is we want. So let's jump right in. So the first thing we need to do is start out in Kansas, of course. And the next thing I'm going to do is share my screen with you. So if you'll see my screen, you'll see that I am in my browser. I have Google opened up. Now, to run and execute the Ruby language on a computer, there are multiple ways of doing it. For the sake of this presentation and for the sake of if anyone wants to practice on their own afterwards, the easiest way to do this is there's actually a website that we can go to that allows us to type in Ruby, and the computer will understand our Ruby instructions. So I am going to go to a site called repl.it, or repl.it, or you can also just type it into your Google search. And if we click on this, we go to this website, and it's called repl.it. And over here, we can search for a particular language that we want to work with. So the repl.it is a multifaceted website. It allows us to work with all sorts of computer programming languages. But for today, we are going to use Ruby. So I'm going to start typing in Ruby. And you'll see there's Ruby and Ruby on Rails. We're going to just do plain Ruby for today. Now, of course, it just occurred to me that if anyone just joined like right now, then this is extremely embarrassing for me because you didn't hear my explanation of what on earth is going on. So let me just walk you through the various sections in this website. This leftmost section is something we actually do not have to worry about, so I'm going to drag it away so it's not in our way. So that leaves us with two sections. We have this white section on the left hand of the screen, and we have this black section on the right hand of the screen. So the way, or one way anyway, that you're meant to use this website is that you can type in Ruby code on the left side of the screen. We will then hit this button here called Run, if you see my mouse is hovering over it, and that will produce a result on the right hand of the screen. So let's jump right in. The first command of Ruby code that's good to know is puts. Puts basically will display something on the right hand of the screen. So if I say puts 1 + 1, and then I hit this Run button, I'm going to make this a little larger so it's easier to see. I'm going to hit this Run button, and you could see that on the right hand of the screen, we see the number 2. Now, we also see this green thing. So anytime you see this green thing in Replit for today's webinar, just ignore it. I believe there's a way to hide them. If I add a file, don't worry about what I'm doing here too much, but it's a way to get rid of those green things, which could be a little annoying. So okay, so I got rid of the green things. Don't worry about the green things. Don't worry about what I just did. But getting rid of the green things avoids certain confusion. So now, going back to what we've done here, I've done puts 1 + 1. So as most of you know, 1 + 1 is 2. So that produces a 2 on the right hand of the screen. So the puts keyword is a special Ruby word that says take the result of whatever comes after this puts and print it out, which means to display it on the right hand of the screen. So puts 1 + 1 produces 2 on the right hand of the screen. If I do puts, let's say 5 - 2, you all know that will produce 3. If I can do multiplication as well. Now to do multiplication in Ruby, you have to use the asterisk, which is it appears on top of the 8 key. So if I do puts 5 × 5, then we get 25. Now to do division, you use the /. Don't ask me who invented that, but if we do 12 divided by 4, we get 3. So this is a simple way of doing math with Ruby. So each time we run this line of Ruby, what we are doing is we are instructing the computer. We're telling the computer an instruction. Hey, computer, do this on my behalf. Take 12 divided by 4 and puts it, meaning have it display on the right hand of the screen. So we can also print out numbers straight up. So I can just put 50, and the 50 appears on the right hand of the screen. In addition to numbers, we can also print words. Now, the technical term for words and characters inside Ruby, these things are known as strings. Now, to work with strings in Ruby, you basically put a bunch of characters in between quotation marks. So if I say puts Dorothy, then we will see Dorothy on the right hand of the screen. If I do Auntie M, then we see Auntie M on the right hand of the screen. Are there any questions? Okay, at any time, feel free to ask questions. Okay, the next thing that I will show you is that just like you can add numbers together, right? We saw it puts 2 + 2 is 4. You can actually add strings together. There's a more technical term for it called concatenation, but I just like calling them adding because that makes more sense to me. So if we do puts toe plus toe, then we get Toto, which is Dorothy's dog. Now, this is where things get crazy. What would happen if I would do toe minus toe? So you might start guessing, but I'm going to hit the run button here. And this is definitely perhaps not what we expected. What we see here on the right hand of the screen is what's called an error. Basically, something went wrong. And Ruby says, this command is invalid. This is an invalid Ruby command. I don't know what you're talking about. Now, it looks like gobbledygook, but if we break down this error message, we can perhaps reason as to what Ruby is telling us. Ruby is giving us, sending a message, why this line of code is invalid. So there's this traceback bit. Okay. Now, there's this main.rb bit, but I want to focus in on this one. This one right here says, hey, there's a problem on line number 1 of your code. If you look here on the left hand of the screen, you can see this one here. If I would put in other lines of code, you see it counts the lines of code. So 1, 2, 3, 4. Ruby is saying there's a problem on line number 1. Now, of course, in this example, there only is a line number 1, but that's where the problem is. That's where the error is taking place. Now, if we jump a little further, we can see this. Undefined method minus for the to string. In English, what that's saying is, hey, you're not allowed to use a minus in the context of a string. So even though we could, quote unquote, add strings together with a plus sign, that's perfectly valid. And toe plus toe gives you Toto. However, in Ruby, there's no such thing, or it's invalid to attempt to subtract a string or to subtract something from a string. So it does look like gobbledygook, and I haven't explained every last bit of this error message. But as you learn to code, you will learn that understanding how to read, how to understand these error messages is key to solving your problems, because you will get error messages. Often code doesn't work the way you intend it. So it's good to know what is going wrong. Let me, just to expose you to some more errors. Another way we can get an error is to divide something by 0. Now, I'm not a math whiz. I know that 2 plus 2 is 4, but that's about it. Well, the truth is I know plus, minus, times, divide. I know like exponents and fractions, and like that's it. Most people think you have to be a math whiz to know how to code. I am proof. Well, I don't know if this being a lion if you put a lot of stock in this, but I am proof that you can be a coder without knowing math. In any case, if you did know math, you would know that in math, you cannot divide things by 0. So if we attempt to do that in Ruby and we say puts 10 divided by 0, we get an error message. Now let's dive right into it. We can see that there is an error on line 1. And what is the error? It is divided by 0. That is the name of the error. And it's saying, hey, you're not allowed to divide by 0 in Ruby. So we encountered another error. I am going to make another error happen. I'm going to type in the word tornado. So here we see that there's a problem on line 1. And what is the problem? Undefined local variable or method tornado, which in English, Ruby is simply telling us tornado is not a valid term in the Ruby programming language. So there are many different types of errors that you can get, and there is no problem with causing an error. Nothing drastic happens. You haven't killed anyone. our friend here was not killed by an error. It was killed by a house. So the error messages are actually a good thing, because when something does go wrong, you can actually understand what the problem is so that you can fix it. Now, apparently, there is a side effect of typing in tornado into Ruby, because now we are at Oz. So I like Oz a lot better because Kansas is all black and white. So I'm actually pretty happy to be here. So let's introduce the next part. I'm going to share my screen again. And we are going to introduce another Ruby command. And this is gets.chomp, and you'll see what I mean. So we're going to, this is going to be a multi-line program. So the first line is, who is your favorite Oz character? Now, if we just run that, then the words, who is your favorite Oz character, that appears on the screen. But we're going to add more lines of code to this Ruby program, because a Ruby program can contain multiple, and usually does contain multiple lines of code. So here, I'm going to do gets.chomp. And then after that, I'm going to say mine2. And let's see what this does. So I'm going to run this Ruby program. So it says, who is your favorite Oz character? Now it's actually expecting us. Gets.chomp asks for the user at this point to type something in to the right side of the screen. So I'm going to say the Wicked Witch. And then the program continues to say mine2. So gets.chomp is a special Ruby command that allows the user to type something in. Now, the truth is that if anyone knows a little bit about Ruby, you're probably wondering about the following, so I'll just nip this in the bud. The truth is, if you just say gets, that will accomplish the same thing. As to why we do gets.chomp, that is it helps process the information better, which will make some of the future code that we're going to be writing tonight easier to work with. That's all I'll say for now, so I'm going to leave it sort of vague, but we're going to always use gets.chomp as a way to ask the user to type something in. Now, let's dive right back into the multi-line aspect of this program. So there's 3 lines here. One of the keys to understanding coding is to understand that in Ruby, and in most other programming languages as well, the computer reads and processes one line of code at a time, from top down. So when we run this program, Ruby first reads and processes line number 1. Line number 1 is an instruction to Ruby to take the words, who is your favorite Oz character, and display them on the right hand of the screen. Ruby does that, right? Ruby executed that line. And that's why we see who is your favorite Oz character on the right hand of the screen. Then Ruby gets to line number 2, which is gets.chomp. At this point, Ruby processes that line. Gets.chomp is a command that waits for the user to type something in. So note that even though on line 3, the third line here tells Ruby to take the words mine2 and put them on the right hand of the screen, it hasn't happened yet. Ruby has not executed that line yet because it has not finished, Ruby has not finished processing line 2. Ruby processes each line one at a time. And only when that line is finished executing does Ruby move on to the following line. So first, Ruby says, who is your favorite Oz character? Then line 2 says gets.chomp. Let's wait for the user to type something in and hit enter. So we're going to do that now. And I'll say the Wicked Witch. And only then does Ruby get to line number 3 and take the words mine2 and display them on the right side of the screen. So I believe we have a question. So Kathy wants to know, what is Ruby usually used for? What type of programs? And that's an awesome question. So Ruby was written by a Japanese programmer back in the mid-1990s. At the time that he had written it, it was not a popular language. It was just a multi-purpose language that people can use to do various things. However, about 10 years after that, so around 2005 or so, Ruby became all of a sudden very popular to write, they use Ruby to write web applications, basically websites that have some functionality to it. So a lot of popular websites are written in Ruby. Offhand, I know Hulu is written in Ruby. Twitter was originally written in Ruby. So Ruby has become popular, especially for building websites. Now, Ruby still remains a multi-purpose language, and you can write all sorts of programs with Ruby. However, Ruby is usually most associated with web development because that is what made Ruby popular. Cool. Does that answer your question, Kathy? Okay. Let's move on to the next part. So the next thing we're going to encounter is a very critical concept in pretty much all programming languages. So let's bring back what we had here. What if we wanted to write a program that takes what the user typed in and does something with it? So we'll keep it very simple in this first example. Let's say we want a program that says, it will say, who is your favorite Oz character? The user will type something in, and the program will then proceed to say, your favorite character is so-and-so, whatever you typed in. So basically, we'll spit back whatever the user typed in. So let's write that program. So who is your favorite character? That's already good to go. Line 2, gets.chomp, that's where we wait for the user to type something in and hit enter. Now, if we want to do something with what the user typed in, it's often useful to store it somewhere temporarily so we can access that information in further lines of code. So we're going to do that as follows. I'm going to say character equals gets.chomp. And this basically takes gets.chomp, meaning it takes whatever the user typed in, and it stores it in this little box called character. Now, in programming speak, this box is known as a variable. A variable is just pretty much like a box. It's a little storage container that can store one thing in it at a given time. And the reason we're doing this is because, as you'll see in the next line, we're going to say your favorite character is, and then remember how we can add two strings together? We're going to do that here. Your favorite character is character. Now, we're going to run this. Let's see what happens. So, who is your favorite Oz character? We're going to say the Wicked Witch. And it will say, your favorite character is the Wicked Witch. So how do we pull that off? Let's go through the steps again of the code. So the first line says, who is your favorite Oz character? It tells Ruby. Ruby tells the computer, take those words and put it on the right side of the screen. Then we say character equals gets.chomp, which says, let's do the gets.chomp. Let the user type something in. And whatever the user types in, we're going to store that temporarily in this variable called character. We can then use that box, that variable, later in line 3, where we say, put your favorite character is character. When we refer to character here, we're not referring to the string character because it's not within quotation marks. Instead, we are referring to the variable character. And since the variable character is a box that holds, in this case, whatever the user typed in, that ends up, whatever the user typed in and is now stored in the character variable, ends up getting displayed on the right-hand side of the screen. So the right-hand side of the screen successfully says, your favorite character is the Wicked Witch. Because we said puts, meaning print the following to the right side of the screen. Your favorite character is, we take those literal words and put them on the right side of the screen. But then we add to the end of that sentence, character, which is the variable, And instead of actually taking the word character and putting that on the right side of the screen, instead, Ruby understands character is just a variable. I don't care about the box itself. I care what's in the box. And since what's in the character box is whatever the user typed in, that input is what gets displayed on the right side of the screen. Does that make any sense? Any questions about that? Let's see. Okay, so variables can be a little tricky when you start getting used to it, but you quickly get used to it. So we're going to end up using variables quite a bit in the rest of this webinar. So is it hot in here or is it just me? Let's move on to another fundamental concept that applies not just to Ruby, but to pretty much every programming language. This concept is called a conditional. And let me explain it. Let's say we wanted to write a program that starts out the same way as the previous program. So it will print out who is your favorite Oz character on the right side of the screen. We're going to let the user type in a response. And we then want to respond. We want the computer to display different responses depending upon what the user typed in. So here, we pretty much just spit back what the user types in. But what if we wanted to make a program that says, if the user types in the Wicked Witch, we can say, hey, mine too, that's also my favorite character. But if the user types in a different character, we can say, oh, that's not my favorite character. So the computer becomes smarter. It responds differently to different responses. So to make that work, we need to use this important concept called a conditional to get the program to do what we want. And again, everything about coding is just getting the computer to do what you want. Computers take things very, very literally. You have to be very explicit when you write your code, because these are the explicit instructions to your computer so that your computer can understand exactly what it is you want to accomplish. So let's start out with the first two lines. So again, we say puts who is your favorite Oz character. We then take whatever the user types in, store it in this box, in this temporary variable called character, and then we can say as follows: if character is the Wicked Witch, and I'll go back and explain this momentarily. Let's make it a little smaller so we can fit it all in. Then we want to say mine too. Else, meaning if the user types in anything other than the Wicked Witch, we will instead say, well, let's agree to disagree. And then we say end. I'll explain all of this in a second. Let's run the program and see what happens. So the program says, who is your favorite Oz character? It is now waiting for the user to type something in. So I'm going to say the Wicked Witch. To which the computer responds, mine too. The computer is saying that the Wicked Witch is also its favorite character. Now let's run the program again. Who is your favorite Oz character? And we're going to say Toto. Then the program says, well, let's agree to disagree. So this whole concept of conditionals is an extremely powerful concept because it allows computers to respond differently to different situations. Let's go back into the code and explain how each line works. So we understand the first two lines. We print out who is your favorite Oz character on the right hand of the screen. We then get the user's input and store it in a variable called character. Then we say if character equals the Wicked Witch. So equals is the Ruby way of testing to see if two things are equivalent. So if the character, that is if the variable, if whatever the user typed in, which is now stored in that variable, is equal to the Wicked Witch, if it is that string, if when the user types in the Wicked Witch, if when the user types in input, that is the Wicked Witch, Then we print out mine too to the right hand of the screen. Else, meaning however, if the user types in anything other than the Wicked Witch, we then say, instead, we print to the right hand of the screen, well, let's agree to disagree. End is a requirement on Ruby that says, hey, if you ever started a conditional like this, you need to put an end on it. Because we need to signal that, let's say, we want to put in another line of code on line 10 that says, thanks for your response. If I run this, who's your favorite Oz character? We'll say Dorothy. Well, let's agree to disagree. Thanks for your response. This line of code, thanks for your response, will happen no matter what the user types in. So this structure here, this is the conditional. This is the piece of code that runs differently based on user input. However, once we get past the end, once the conditional is over, the computer proceeds to process each line one at a time, top down, as normal, no matter what. So no matter what, the computer will eventually get to line 10 and will therefore print the words, thanks for your response, in the right hand of the terminal. Now, this is really the first exception to the rule that we said earlier. We pointed out earlier that Ruby reads each line of code one line at a time and executes it one line at a time. So Ruby reads and executes the first line, and only when that line is completed does it move on to line 2. Only when it completes executing line 2 does Ruby move on to line 3, and so on and so forth. However, this, when we're dealing with conditionals, there's a little bit of a deviation here, because if you connect the dots, let's analyze which lines of code is Ruby running. So it always runs line 1, it runs that first. Then it moves on to line 2 and runs that, waits for the user input. As soon as the user input is typed in and the user hits enter, Ruby moves on. We then get to line 4. This line runs no matter what. It says if the input that the user typed in is the Wicked Witch. Now at this point, Ruby doesn't go just straight down, boom, 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 one line at a time. It depends. It depends on what the user typed in. So if the user did type in the Wicked Witch, then Ruby processes line 5 and then skips all the way down to line 10. Now, in the case of where, let's go back up to line 4. Let's say we're up to line 4. If the user types in something other than the Wicked Witch, then in that case, Ruby skips over line 5 and goes down to line 7 and prints out, well, let's agree to disagree, and only then moves on down to line 10. So Ruby still moves from a top-down fashion, but it doesn't necessarily hit every line, 1, 2, 3, 4, 5, 6. Basically, once we introduce conditionals, we now allow Ruby to skip lines as needed and says, hey, if this happens, run this line. But if that happens, run the other line. And again, this is an extremely powerful technique, which exists pretty much in every programming language that I'm aware of. So Jay has a great question. I should have addressed this. What is the purpose of the empty lines? So if you'll note, lines 3 and 9 are completely blank. The truth is that they don't have to be blank. I don't need them. I can run the same program without the blank lines and type in whatever, and the program still works exactly the same. The reason I put in the blank lines is because, to me, it's easier as the programmer to read this code and understand this code when I put lines between concepts. So line 1 and 2 are pretty straightforward. We are now introducing a conditional, which is a little bit tricky. So I put a blank line before it and afterwards to sort of isolate it and make it that the programmer can easily read it as an isolated unit. However, you don't need it. And the way Ruby works is that if it encounters a blank line, it just ignores it and moves on. So it's more of a technique for the programmer. It doesn't really matter to the computer. It's an awesome, awesome question. Okay, now let's make this one step more complex. Now in this program, we have two choices, right? Either the user types in the Wicked Witch, or the user types in something else. And the computer is ready and waiting to respond to one of two possible choices, the Wicked Witch or anything else. But what if we wanted to allow the computer to respond to more than two choices? So let's say we want to say something particular to the Wicked Witch. But we want to say something else if they say the Cowardly Lion, and then something else to all the other responses. So to do that, the way you do it in Ruby, and again, it's important to stress that there is no, computer science is not a natural science. The fact that we write this code in this way is simply because the inventor of Ruby arbitrarily said so. So this is just the way Ruby works. So we use this special keyword called else if, which is not English, even though the if was English and the else was English, but for some reason there was a deviation with else if, and instead of writing it as like else if, which would be English, it's this else if, one word without a E in the middle, without a second E. Else if character equals the Cowardly Lion. Then we'll say, hey, did you know that he wrote this program? So now let's see what happens when he runs this program. Who is your favorite Oz character? If we say Toto, it still says, well, let's agree to disagree. Let's run the program again. Now we'll say the Wicked Witch. It says mine too. But let's run the program a third time, and this time respond with the Cowardly Lion. Then it does this alternative response. Hey, did you know that he wrote this program? So this is like a big fork in the road, right? There is 3 possibilities we can go down, and we'll address each possibility separately. So if the user types in the Wicked Witch, we'll run line 5. If the user types in the Cowardly Lion, Ruby runs and processes line 7. If there's any other response other than those 2 predetermined ones, we'll simply give this canned response of let's agree to disagree. I think I saw okay, we have a question from Tamika. How do you capture the witch or the Wicked Witch of the West, etc.? Yeah, great question. So let's run this program. What happens if I type in the Wicked Witch of the West? Right, I'm very particular. There's more than one Wicked Witch, as you know. It's going to say let's agree to disagree. Meaning, going back to what I said before, computers are so literal. They don't have any human intuition. Despite everything that's going on with artificial intelligence, at the end of the day, computers have no human intuition, and it's a dumb piece of metal. And that's why we have to be extremely literal when instructing it with computer code. So on line 4, when we say if the stuff the user typed in is the Wicked Witch, it has to be the Wicked Witch exactly. If we deviate from there an iota, the computer will say, hey, the user didn't type in the Wicked Witch. The user typed in the Wicked Witch of the West. That's something else. The computer is not smart and assumes that it's supposed to default to this canned response of, well, let's agree to disagree. Let's make this case even stronger. Let's say we say the Wicked Witch. And note what I did here. See how the W from wicked I made a lowercase? Even there, the computer will not recognize it because in our code, we say the Wicked Witch exactly like that. Only if the user types it in exactly that way will the computer say, well, that's what the computer typed, that's what the user typed in, I'll respond with line 5. If there's any deviation, even in terms of the casing, and we enter a lowercase instead of uppercase, the computer says, well, the computer didn't type in this string. The user typed in some other string. It's close, but no cigar. Now, how would we as programmers deal with that? It would be annoying to write out every permutation, every possibility of the Wicked Witch. And it's actually not so easy to deal with these kind of problems, but there are other things built into the Ruby programming language that makes this easier. There's something called regular expressions that it's a more flexible way and will allow us to write code that says if the user types in something that has approximately these characters, or maybe starts with this character and ends with that character, but we're more flexible about what's going on in the middle. There's regular expressions is a powerful tool, which we're not going to get into tonight, but that's the common way that we deal with these kind of issues. But this definitely highlights how literal the computer understands things. And that's really, people think that coding is like rocket science, you have to be super brainy. It's really not that. The art and science of writing computer code is shifting your mindset and understanding how to speak in a literal way to the computer? How do I tell this dumb piece of metal, the computer, how do I tell it to do what I want when it doesn't understand anything from anything? It only understands very literal instructions. How do I, it's a different mindset to adopt, and like, how do I get the computer to do what I want, and with just a mere set of literal instructions? So I saw another comment here. So yes, you can definitely add, sorry, there's a few questions here. Sarah asks, if you wanted to add special responses for more characters, would you just continue to use the else if? Great question. So let's say we wanted to deal with another possible character. Yes, you can use as many else ifs as you want. So we can say else if character is the Tin Man. We can say awesome. And we can go on and on and on. So you can only use one if, and these are the rules in Ruby. You can use one if, you could use one else, but you can use as many else ifs as you want. So we can write this really long program to deal with every character in the Wizard of Oz. And that's a great question as well. Okay, let's move on to another core concept of programming. And this is best demonstrated if you see this video. That's me right over there. So one of the scariest parts of the Wizard of Oz is when we encounter these soldiers. There must be a name for them. These soldiers that sing O-E-O-O-O or something like that. I saw there's a debate on the internet as to what exactly they are saying. We're going to just say it's O-E-O-O-O. Now, what if we wanted to write a computer program that replicates that song and basically prints out the lyrics of that song? Because that's, you know, a really very useful program. So the way we know how to do it now is we can say O-E-O-O-O. And we can then, now they say it multiple times. So if we want to really print out the full lyrics, we can copy and paste that line, and let's say they say it 10 times. I didn't actually count it. Boom, on the right side of the screen, we now have the lyrics to the soldier's song. Now, computers are really good at automating things and making things easy for humans. They're really good at repeating tasks. It seems silly that to get the computer to say O-E-O-O 10 times, we have to write 10 identical lines of code to do so. And that's where the concept of loops helps us. So let's write an alternative version to this. It's going to produce the same result, but we can do it in 3 lines of code rather than 10. We're going to say 10 times do end. Let's run that. And now we got O-E-O-O 10 times. If I change this number to 100 times, we get O-E-O-O 100 times, which is really good, because let's say your boss comes to you and says, I need O-E-O 1,000 times by Thursday. That might be annoying to write that code. So all we need to do is like, yeah, sure. We can change this 100 to 1,000. And this is what computers are good at. They're good at automating tasks. So let's go back into the explanation of this code. So 1,000 times do, and then at the end we have an end. Basically, this is the construct called a loop, which basically means we're going to loop over the same code, in this case 1,000 times. So any code that goes in between the do and the end will run 1,000 times. We can put multiple lines of code in between the do and the end. I don't even know what we put in. Maybe some more exclamation marks. Let's see what happens. So it basically runs O-E-O-O-O, triple exclamation marks, then goes back up to the top, and runs these 2 consecutive lines again, and then goes back up to the top and runs these 2 consecutive lines of code again. So basically, we can take any group of code and wrap it inside of a loop so that Ruby will run that section of code multiple times in a row. This is the biggest exception to the big principle I said at the beginning of the webinar. If you'll recall, at the beginning of the webinar, I said the way Ruby processes code is 1 line at a time from top to bottom. This is, it's an exception, but it's not an exception. So yes, Ruby starts at line 1, then moves down to line 2, then down to line 3. But when it hits the end, it jumps back up again. And we start back up and run line 2 and 3 again. And then we skip back up. It's not skipping, it's like reversing. It's going back up to line 2. We run 2, 3. And back to 2, 2, 3, 2, 3, 2, 3. And only after it runs lines 2 and 3 1,000 times will the program then proceed to run any lines of code after it. So if I want to say, let's get out of here. So it runs OEO exclamation marks 1,000 times, and only after that entire loop has been completed does Ruby go on to line 6 and say, let's get out of here. So as you can imagine, loops are another critical concept of programming, just as conditionals are. And Jay has a great question, which is, why are lines 2 and 3 indented like this? And this is similar to the concept of having blank lines. You don't have to. This program would run just as well if I remove the indentation. However, this is basically, it's helping the programmer read this code more easily. By indenting lines 2 and 3, it allows us as the programmer to look at this code and just quickly visually recognize to say like, oh, it's really easy to see now how lines 2 and 3 are wrapped inside the loop. So yeah, I noticed a couple people were raising their hands. The best way to ask questions is to use the chat feature. So if you can type in a question into the chat section, that's the way I'll be able to see it. So just letting you know. I should have made that clear at the beginning. Okay, let's move on. Now there's actually a, well, let's first get to perhaps the scariest part, or maybe the second to most scary part of Wizard of Oz. And this is when the Wicked Witch of the West takes out the hourglass and says, do you see that? I'm the lion, so I'm not going to do the impression of the Wicked Witch, but that's how much longer you've got to be alive. And it isn't long, my pretty. Now, I don't know how it works. I don't know the magic behind it. But somehow, when that hourglass runs out, then Dorothy dies. So if we wanted to write a program that replicates the hourglass, we can do so. Before that, though, I noticed there was a question. Yeah, so Keith points out that when working with HTML and CSS, and really the truth is even with Ruby, depending on which program you're using. So right now we're using this REPL website in order to write our code. Wherever you type, there's different places you could type your code into, and depending on which program you're using, they might automatically indent your code to help the programmer. So in this case, with REPL, you have to manually do it, but there are other programs you can use to write code inside of it, and it will automatically notice hey, that's a loop. Let's automatically take the stuff within the loop and indent it to make it more visually readable. Yeah, good point. So let's get to the hourglass. Now, to build up to the hourglass, let me start with a simpler example. Basically, what I'd like to do is let's print out all the numbers from 1 to 100. So 1, 2, 3, 4, 5, blah, 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 99, 100. How would we write a computer program to do that? So we're going to use a variable. So this is where, so we learned about variables, we learned about conditionals, we learned about loops. Now these concepts are going to tie together. We're going to make a variable called number, and we're going to say that it should be 1. So again, a variable is like a temporary little box that's used as a container to hold something. So in this case, we're creating this variable called number, and it's going to contain the number 1 within it. We'll then start a loop and say 100 times do. I'll put the end already to make it easy. And now within this loop, we're going to say puts number, basically take the number variable, whatever number it's holding, and print it to the right side of the screen. And then number plus equals 1. So this is the first time we're encountering plus equals. Plus equals is the Ruby way of saying, take that variable and take the number in it and increase it by 1. Let's see what happens. So on the right side of the screen, we can see it says 1, 2, 3, 4, 5, and it prints out all the successive numbers up to 100, basically achieving our goal. Let's go back to the code to analyze how this works. So again, on line number 1, I'm establishing a variable called number, and it's going to hold the number 1. Then we start this loop that is to run 100 times. And that means lines 4 and 5 are going to circle around, loop around 100 times. So we're going to run lines 4, 5, 4, 5, 4, 5, 4, 5, 100 times. And so let's walk through this. So on line 4, puts number. Since the number variable is holding the number 1, the number 1 gets printed to the right-hand side of the screen. We then move on to line number 5 and says number plus equals 1. So since number was 1 until now, when we increase it by 1, the number variable is now holding the number 2. We then loop up back to line number 4 and puts number, but this time number is number 2. And we print the 2 to the screen. And then we proceed to line number 5. Number plus equals 1. It says take the number inside the number variable and increase it by 1. So as of this moment, number is holding the number 2. We then, this line 5 takes the number within the number variable and turns it into 3. And so on and so forth. So when communicating with another human, if I were to say, hey buddy, can you write out the numbers 1 to 100? They'd probably look at me funny, be super annoyed, but if they had to do it, they would do it. You cannot tell a computer to do that. You cannot tell a computer the words. I can't type in the words here to say, print out numbers 1 to 100. Ruby will not understand that. Instead, we have to go through these wonky literal instructions to basically like trick the computer into printing out numbers 1 to 100. Even when the computer is running this code, it doesn't even know what it's doing. It doesn't know that it's trying to print out numbers 1 to 100. We're like tricking it into doing that because we're basically saying, hey computer, please, can you follow these literal set of instructions? And the computer is like, yeah, I'm Mr. Literal or Mrs. Literal. And it says 1. So again, let's just go through the lines of code again. On line number 1, we have a variable called number, that's 1. We then start a loop that is to run 100 times. We print out the number. In the first case, it's 1. We then increase the number variable, and it becomes 2. We then go back up to line 4. We print number, which is 2. And then we get to line 5, which increases the number variable to hold the number 3. And so on and so forth. And we essentially have tricked the computer, so to speak, into printing out all numbers from 1 to 100. So yeah, so Keith points out that this type of thinking is pretty much true. He mentioned JavaScript, but it is pretty much true in almost all programming languages. He also uses a great term called algorithms. Algorithms, which sounds like a scary word, simply means a set of instructions to the computer. And it's, learning how to write these types of algorithms is not a matter of being a genius, it's a matter of practice. It's like I'm used to communicating with other humans, but how do I tell the computer to do what I want? How do I give it a interesting set of literal instructions to trick the computer into accomplishing my goal? That's just a different way of thinking that no one is born with. some people catch on to it more quickly, but no one's born with understanding that. And it's just a matter of practice. And the more you practice talking to a computer and writing these algorithms, the better you get at it. Okay, so if we wanted to replicate the hourglass, we can do as follows. Let's make a variable called grains of sand. Now you'll notice that I use these underscores here. If I were to put spaces here, Ruby would not like that. Ruby says that's a problem. You can't have a variable that contains multiple words with spaces. We need so if we want to make a multi-word variable, we need to do something like this. The most common way of doing that in Ruby is putting these underscores. So let's say grains of sand, let's say the hourglass contains 10,000 grains of sand. It probably contains more, but let's just work with that. We will then say 10,000 times do, print the grains of sand, whatever that variable is holding, print that to the right-hand side of the terminal. And then grains of sand minus equals 1. So you can probably guess what minus equals does. It's the converse, or is it inverse, of plus equals that basically says, let's take the number inside the grains of sand variable and decrease it by 1. So if we run this, look how fast that went. Basically, the program started up. It takes you longer to scroll up than it does, I'm not even going to bother, than it does for Ruby to actually run it. That's how fast computers are. It basically prints out all numbers from 10,000 all the way down to 1. Now, we can put this in, so you're dead. So, of course, once the, well, let's get the grains of sand to be 0. So we'll have to let the loop run one more time. If we run it this time, it prints out 10,000 down to 0 and then says you're dead. Once we got past the loop, Ruby proceeds past the end keyword. The end keyword is like that gatekeeper that says, hey, we're not done with the loop yet, move back up to the top. Once we're done with the loop and have gotten through it 10,001 times, Ruby then proceeds down to line 8 and says you're dead. Sort of morbid, sorry. Can you use scientific notation? I think you can use scientific notation in Ruby. However, since I have never really done that, as far as I recall, I'd have to look up how to do that. But good question. Okay, we're running out of time, so let's get to the most important part of the Wizard of Oz, and that's getting back home. So if you've watched the movie or read the book, you know that Dorothy has to tap her ruby slippers 3 times, and she says there's no place like home. Now, I counted it. She says there's no place like home 5 times until she gets back, and that's after that she gets back to Kansas. So if we think about it, the way to get back home is to tap our heels 3 times, but also say there's no place like home 5 times. Let's write a program that replicates that experience. Now, one thing I'll have to show you first, a new concept that I haven't introduced you to before, is all the loops we've done until now run a finite number of times. We declare, run this loop 10 times, 100 times, 10,001 times. But you can also make a loop that runs forever. It's called an infinite loop. Watch what happens. You might not want to watch what happens because then you might be here forever. So let's print infinity and run that. So this program is running infinity forever. It's not stopping. If I want to stop it, I have to click the stop button. Oh man, I'm stuck. I have to click this. I better get out of here. I'm going to refresh the page. That's my only way out of it. The stop button officially should stop the program, but if it doesn't, then we're going to refresh the page. That may have been a really bad idea. Okay, let's get out of there. Okay, let's go to, so I've pre-written this program of getting back home. Now this is definitely the most complex program we've written yet, and it combines all the concepts we've learned into one. It combines variables and user input and conditionals and loops all together. Let me run it, show you how it works, and we can then go through the code. So when I run it, it immediately expects user input. Now, to tap my shoes, now we have to tap our shoes 3 times. To tap my shoes, I need to type in the word tap in all caps. And, oh, okay, it froze for a little bit. If I want to say there's no place like home, then I type in there's no place like home. I need to get in 3 taps and 5 there's no place like homes in order to get home. So if you look so far, we got our 3 taps in. We got 2 there's no place like homes in. We need to get in 3 more there's no place like home. Welcome to Kansas. So this program basically waits for user input, and only once the user taps their shoes 3 times and says there's no place like home 5 times will the user get back to Kansas. So let's walk through this. If you don't get it all in this one sitting, that's fine. It takes a while to sort of break this down and analyze it, but I will attempt to explain it. After the webinar is over, I'll also, everyone who attended, I'll send a way that you can access this code. Let's take it from the top. On line 1, we make a variable called shoe taps. This is going to be a variable that keeps track for us of how many times the user tapped their shoes. And since at the beginning of the program, before it starts, the user tapped their shoes 0 times, we're going to set it to be the number 0. We then say no place like home. We're making a no place like home variable that counts how many times did the user type in there's no place like home. And we also set that variable to be 0. We then start an infinite loop. Now, at first blush, that seems scary. We don't want to start that infinite loop, but you'll see there's a way to break out of an infinite loop. So we start this loop, and that means all the lines from 5 down to 14 are within this infinite loop, and Ruby will run lines 5, 6, blah, 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 14, and then go back up, 5, da, 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 14, da, 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 5, da, 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 14, and we'll run lines 5 to 14, top down, back up top, forever and ever. Now let's look at this code carefully. We make another variable called phrase, and that will we'll take the user input and stuff that into this variable called phrase. We're now working with 3 different variables. If phrase is tap, meaning if the user typed in tap, then shoe taps plus equals 1. We're going to take the number inside the shoe taps variable, which when we start the program is 0. We're going to increase it by 1. Else if phrase equals there's no place like home, if the phrase that the user typed in is there's no place like home, then we take the no place like home variable and we increase it by 1. Okay? So every time we run this loop again, we ask for the user input on line 5, and depending on what they type in, we either increase shoe taps by 1 or we increase no place like home by 1. And if they typed in neither of them, let's say they typed in gobbledygook, then we do nothing. We don't react to that. But we do move on to line 12. And this introduces another new piece of syntax, and that's the double ampersands, which is just a way of saying and in Ruby. So we also have the greater than sign. So let me read this in English. If shoe taps is greater or equal to 3, meaning if the shoe taps variable is 3 or higher, and the no place like home variable is 5 or higher, then break. Break is another new keyword in Ruby. Break says, get me out of this loop and move on. So even though we had an infinite loop going on, if we ever say break, we say, let's just exit the loop and then move on to line 17, and welcome to Kansas. So our algorithm here, our way of, our set of instructions to the computer is say, hey, keep on asking the user to type in something forever. However, if they end up typing in the word tap 3 times, and they also type in the word, the phrase, there's no place like home, 5 times, then break out of the loop, go to line 17, and finish the program. Welcome back to Kansas. There's a lot here. Any questions about what's going on here? This is complex. We've got variables, user input, conditionals, and loops. A lot of stuff going on here. Again, it's just a matter of getting used to it. It's a matter of practicing. That's how you get good at this stuff. But this is, although we're using Ruby to demonstrate these concepts, what we're demonstrating here, these are the fundamentals of coding in pretty much all programming languages. Oh, so Jay wants to know, okay, and Kathy, well, let's go back, we'll do Kathy's question first. Okay, a lot of 3 questions. Okay, let's do these one at a time. I'm gonna start with the easiest one. So on line 12, if shoe taps is greater than 3, and, so and, the double ampersand is, in English, is just saying and. So if shoe taps is greater than 3, or greater is 3 or higher, and no place like home is 5 or higher, if both of those conditions are true, then and only then will we break out of the loop. So it's making sure 2 different conditions are both true. Saying, we're not going to send you home if you tap your shoes 3 times, but you didn't say there's no place like home 5 times. And if you just said there's no place like home 5 times, but didn't tap your shoes 3 times, we're also not going to send you home. You need to do both. You need to do this and this. So if the shoe taps is 3 or greater, and no place like home is 5 or greater, if both of those conditions are true, then we break out of the loop. I hope that makes sense. Moving to the other questions. Okay, questions are building up. Alexandra wants to know the difference between end and break. So break, on line 13, that is the line that exits out of the loop. End is the gatekeeper that says, hey, Ruby, this end is the closing part of the if statement. And let's go back. This will be a little easier if we work with a simpler example. So if I say 10 times do puts hello, end, how does Ruby know what's part of the loop, what's outside of the loop? Let's especially say we say something on line 5, the end. So we say hello 10 times, and then we say the end. So the do and the end are basically the beginning and end of the loop. So end is not a way of like getting out of the loop. Break is how do you get out of a loop. End is just saying, this is the bottom of the loop, and if we haven't done running it all the times, go back to the top and run the next loop. So think of it as just like it just encapsulates the code of the loop. So since puts hello is between the do and the end, that's the code that gets run 10 times. But line 5 puts the end, that only gets run 1 time. So end is like the end of the loop. But once you hit the end, you still have to go back up to the top of the loop and run it again. Similarly, when it comes to if statements, we need to use the end statement. So if, let's say we say character is gets.chomp. And we say if character equals Toto, do something. Cool. Thanks for your answer. So if we run that, we type in Toto, cool, thanks for your answer. Or if we run it again and say Tin Man, it just says thanks for your answer, but it doesn't say cool. Over here, the end is basically, it's also, this is it's encapsulating the conditional. It's saying, hey, this line 4 puts cool. That should only happen if character is totem. But the end of line 5 says, okay, the conditional is over. Everything below this should happen no matter what. So line 7, thanks for your answer, will always run no matter whether the user types in toto or something else. So the end, it's a little tricky. End doesn't mean like end something. It's just basically saying like, hey, this is the bottom of it. This is the end of the conditional. It's the bottom of the loop. Go back up to the top. Or end, in the case of the conditionals, the conditional ends here. Break, however, is something different. Break is basically saying if I'm in the middle of a loop, then we're going to yank me out of the loop and skip all the way past it. So even though we're on line 13 over here, if we encounter break, it's going to immediately skip to line 17. Now, another person asked, hey, why on line, we have 2 ends, line 14, line 15. So this is also where the indentation helps. If you look carefully, the end on line 14, that is the end of the conditional that begins on line 12. However, the end on line 15, that is the bottom of the loop that begins on line 4. So this is complex because we have a conditional statement, actually I have 2 of them, inside a loop. So we need one end to tie off the conditional, and we need another end to tie off the loop. So let's see other questions. So someone wants to know if, hey, you can say and, can you also say or? And yes, you could say or. We'll get into, there's no time for an example, but if you wanted to know to say or in Ruby, you use a double pipe, double vertical lines. So this would read as, if shoe taps is 3 or more, or no place like home is greater than 5, is 5 or more. If either of those conditions are true, but even if just one of them are true, we'll send you back to Kansas. But the way we wrote the code is you need both of them, and both of them need to be true. If the shoe taps is 3 or more, and no place like home is 5 or more, only if both of those things are true do we break out of the loop. Whoops. Other questions? Let's see if I got all the ones. It looks like I did. And since we got back home successfully, thank you for joining me on this super hot journey to Oz. If you're interested in learning more about Actualize or learning to code further, come visit our website, actualize.co. And we, of course, run a boot camp that is a 3-month program that actually takes people who know very little about code. We start with these lessons like you see in this webinar, and we take them over the course of several months to become career ready. And we do this over live video conferencing for everyone in the country in live classes. But it's even better than these webinars, because in this webinar, you can only see me, you can't talk out loud. In our Actualize bootcamp, however, all of your faces appear and everyone can talk to each other and yell and scream at each other the whole time, or at least be interacting in an easy conversation. Our upcoming cohorts begin May 13th. And thank you all for joining. Let me just see if we have other questions before we go. So for those people, I got a few comments that you are taking the course, so awesome. In Actualize, we do use Ruby. We use Ruby and JavaScript. We started with Ruby and then move on to JavaScript because we end up using both in conjunction with one another. To build a good website, you need both. And another question here is, what do I recommend to continue to practice Ruby? So we actually have on our website, if you go down to the bottom, there's a tutorial section. So we have more video tutorials on Ruby. We have some exercises there as well. In addition, if you haven't heard of it, there's a great site called Codecademy, spelled C-O-D-E-C-A-D-M-Y. So there's no A in the middle, or there is a, it's tricky. C-O-D, it's like Codecademy. If you go there, They have introductory free lessons on all sorts of coding, and especially in Ruby as well. Okay, thank you all for joining, and have a wonderful night. And I'll probably send out the invitation to the next webinar in the next couple of weeks or so. In the meantime, have a wonderful evening, and thank you for joining.